Let's work through question 23 from chapter 8. It says, how large of a sample should be selected to provide a 95% confidence interval with a margin of error of 10? Assume that the population standard deviation is 40. So now we have everything that we know over on the left side. We know that our alpha is 0.05. We get that by taking 1 minus our confidence level of 95%. Since our alpha is 0.05, we know that alpha divided by 2 is 0.025. We know that our sigma is 40. That's our population standard deviation. And we know that E, our margin of error, is 10. So now we take a look on our formula sheet and we see this formula for the required sample size. We need the z-score of alpha divided by 2, and then we square that z-score. We multiply that by our sigma squared, and we divide all of that by E squared. So we plug in all of the pieces that we know. We know that we need the z-score of 0.025. We know that sigma is 40, and we know that E is 10. So now when we're looking for this z-score, we are looking for 0.025 in the area portion of the table, in the middle. So we're looking for 0.025, and we notice that that z-score is 1.96. So we have 1.96 squared times 40 squared, all divided by 10 squared. So if we work through this math, we end up with 6,146.56 all over 100. So n equals 61.466. Now, we can't have a decimal in our sample size. In a normal math problem, we would round this down to 61. But a sample of 61 won't be enough. So no matter what the decimal is, you will always round up when you are looking for the required sample size. So in this problem, our required sample size is 62.